Y el OBS listo para grabar. Creo que no me olvido nada. Vale, pues empezamos la clase. Ok, pues hoy toca implementar el tema de Skin Space Ambient Occlusion. Lo vimos ayer. Conceptualmente es muy claro, no tiene mucho misterio, no es como de Ferro, que es una cosa que si no sabes de qué van los tiros te puedes quedar un poco extrañado. Es un tema muy simple, simplemente es calcular un factor que vamos a multiplicar por la luz ambiente para que la luz ambiente tenga un poco más de información de profundidad y poder detectar. Ah, por cierto, debería hablar en inglés ahora que lo pienso. Sí. Voy a empezar la clase en inglés porque aún cabe la posibilidad de que esa alumna que solo habla inglés, que no ha vuelto a aparecer nunca por clase desde hace 2 semanas, quiera ver el vídeo. Así que un segundo. Ok. Okay. So today class, we implement skin space ambient occlusion. The idea is just to have a factor that we can multiply by every single pixel on the screen by the ambient factor, and that it will improve a little bit the illumination, and it will make at least the areas that don't have direct light a little more interesting. Okay. So this being said, let's go to the slides. Quick recap, what we want simply is something that looks slightly like this, but this is the best case, which is the perfect ambient occlusion. So we are going to have to try to compromise with something a little bit worse, and it's going to look something more similar to sorry, 1 second, to this kind of darkness on the corners, okay? So let's go to the implementation details here, which you will see it's very straightforward. I mean, it's just copy pasting mostly, but it's important that you understand it because I'm going to only do the first half, the skin space ambient occlusion. I'm not going to do the skin space ambient occlusion plus, which is, I think it's interesting, but I want you to try to play around a little bit with that. So without further ado, we can implement skin space ambient occlusion for in theory, for both. The problem is that skin space ambient occlusion requires to have a depth buffer pre-generated. And if you want to have the skin space ambient occlusion plus, then you have to have it also the normal buffer, because you need to know for every pixel on the screen what's its depth and what is normal. So that means that I cannot implement it for forward, because in forward, we're computing the illumination during the while we are generating the depth map. Okay, so there's only two ways to generate the, I mean, two possibilities here. You are going to use render forward with skin space ambient occlusion. First is that you have to do a prepass, so you have to first generate the whole scene normal and depth buffer, so you have to render everything twice. Not the best solution, but it doesn't work very bad. I mean, you can do it. I mean, unless you have thousands of objects on the screen, maybe it could be a penalty, but otherwise, because you're not rendering the color, only the normal, it's fast to do that. And also it's going to improve a little bit when you do the forward, because you already have pre-computed the occlusion. So that means that when you generate the illumination, which is a more taxing shader, is going to be faster, because it's only going to be computed to the pixels that are on the image, and like the closest one to the camera. Or there's another option that I've seen for forward that many people do on some engines, which I think is horrible, which is that you multiply the ambient occlusion at the end on top of the whole illumination. And that's bad. It's bad because you're multiplying the ambient occlusion for every pixel, and in that case, that means that you're multiplying the ambient occlusion to the diffuse illumination and to the spectral illumination, which doesn't make any sense. So you do that, you multiply the ambient occlusion at the end. In forward, you're going to get some ugly, well, dark corners that even if you shine like a flashlight to the corner of the screen, still is going to be dark because you're multiplying on top of that. So totally bad idea. So let's go to the third, because the third makes more sense. So I have it around here. My implementation of the third. Let's go directly, to don't waste too much time. So render forward. I don't have a render deferred in this one. That's weird. Let me check again. I did skip because this is the version I was coding the other day. Yes, I have it here. I don't know why it wasn't appearing there. Okay. So here we're creating two buffers. We're creating the G buffers with all G buffers and the final illumination buffer. So I don't know. I mean, if we're going to assume that I'm always going to use the skin space ambient occlusion, I can create it here too. Okay, one doesn't have to be half float. It could be in sync byte because this doesn't have much precision. It's just a value between 0 and 1. So with a byte, it's more than enough. Even we don't need to have RGB. If you think about it, you can have something like I don't know if you can do like this red or like this luminance. But for now, let's go to RGB. And if it works well, we will try to save some memory. It's complaining here because I never defined this variable. I'm going to define the same place where I defined this one. In this case, I can do it here. Although for you, I would recommend you that you do these things on the renderer header on the class, because that means that you can access these properties from outside of the CPP. But for now, I want to go fast. So I'm going to go with super ugly code. As I always say, my ugly code should never be what you do on your assignments, because that means that you are just copy pasting, which is bad. Okay. Also, keep in mind that here I'm making the buffer where I'm going to compute the SSAO. I'm doing the same size as the screen. As I said the other day, that's slow. So we better try to use half of the resolution. But for now, let's use this resolution to see what comes, how it looks. Okay. So first, we generate all the G buffers. And once the G buffers are generated, I can compute the SSAO here, because I have all the information I need. I have here already the def buffer, and I already have the normal buffer. Okay, so it's all I need. And I'm going to render inside here. So obviously, I have to bind this one. We will render something like a full screen quad, and then we will unbind this one. And if everything goes well, at the end, we should have the SSAO. And because I want to see it while I'm developing, always go and show it to the screen. So at least I can see the results of this algorithm while I'm coding it. Okay, cool. More or less, I have everything I need. So let's go here and code. All these kind of things, I always put them in classes, in special functions, things that will help me to move it easy between different engines. Like if I have a nice implementation of skin space and occlusion that I want to use in another engine, I just copy paste this code and I can go somewhere else. Here, I'm hard coding it everything inside the renderer. It's bad, but obviously you shouldn't ever try to do these things in the bad way. It's good to try always to keep the code as clean as possible. So here, I'm going to disable the def test and the blending, because I'm going to compute the pixel for every pixel one value. So it doesn't make any sense to def test because there's no def buffer enabled in this SSAO. Okay. And also, by the way, when I generated this SSAO, when I created here, I could specify if I want the def buffer to be a def texture. By default, is it true? And this value here, or when you create the SSAO FBO, means if you want to have the def buffer as a texture that you want to read from it. And if you think about it, it doesn't make any sense, because I'm not going to use the def buffer on this FBO ever, because it's going to just compute for every pixel some value, and that's it. I'm going to read the def buffer, but it's going to be the def buffer of the G buffers. It's not going to be the def buffer of here. And I'm not going to use def test for anything. So if I put false here, this will make this a little bit faster, okay? And also I could do the same here. If you put here false, it's going to be a little bit faster, because that means that instead of using a def texture, it's going to use what is called a render buffer. Render buffers are a little bit faster because they are in a space of the memory where it's easy to reach by the renderer, but harder to reach by the shader. And in this case, we don't want to read from it. So it's a possibility that you can do. Okay. And that's mostly it. Yeah. Unless you did something like copying it to the def buffer or something like that, and then if you didn't, you will need to have through here if you were accessing the def buffer of this illumination FBO. Okay, so we have the def buffer. We need a shader. Okay, so we have to create a shader, which, by the way, this class shader I have here, and this squad, I'm going to put it on top because I'm going to need this squad probably many times. And so let's go from here. So here, I'm going to define this variable on top also. So at least I don't lose this. I mean, I can reuse this in variable shader for many steps here. And so here, what's the shader? Well, I have to build it. And so let's assume I already built it. I can ask my shader atlas and say, hey, can you pass me the shader for SSAO? And let's hope everything goes well. So if the shader is good, I enable the shader because I'm going to pass some information to the shader. Which information do I need to pass to the shader? First, I need to pass information to reconstruct the position. Remember that I need to know for every pixel on the screen what's its position in world space. So I have to do the same approach as I used previously, which is first send all the G buffers. I don't need all of them because the emissive, I will never use it. So I can skip that. And also the albedo. I'm not going to use the albedo for anything. So I can skip that one. I only need the def and maybe the normal if I'm going to do the SSAO plus. And let's go to here, which is sending the resolution, which, by the way, I don't know why I put this here because this never changes. Well, anyway, I was putting inside the loop. It doesn't make any sense because these variables never change between iterations, so I can put it outside. So let's do the same here. I have these variables, and I'm going to have also this one. And yeah, I think more or less I have everything set up. This camera, by the way, it's created where? Camera. Oh, no, it's passed here. No, yeah. So I have the camera here. Cool. Okay, I have all the information. I want to draw a full screen quad. So if you're going to render a full screen quad, you only have to do this. Oops, here. And okay, with this more or less, I have everything set up. The thing is that the shader is going to need some extra information. I don't have it yet here, but I'll put it. But meanwhile, I'm going to go to the shader. So let's go to my shader atlas, and I'm going to create a new shader. And let's call it SSAO. And this is going to be a quad because it's going to be a full screen quad. Remember, we are not rendering data on the scene. We're not rendering like a sphere, a cube, a mesh. We're rendering just a full screen quad. So it's a quad VS. And let's go like this. And because this is going to be similar to probably, I don't know which one is the simplest one I have always to use. I don't know. I will start with from this one because I think it could be useful. So I'm going to copy this, going to the bottom and put it here. And I'm going to call SSAO. Okay. So I don't need the position. I don't need normal, blah, 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 all out. This is things that I don't need. With the texture, no, but I'm going to need the texture. And maybe I need the normal texture. So I'm going to put them here. And I'm going to need, it's going to only have one output, which is the flag color. So nothing else is required here. And yeah, for the rest, I can kill most of it. But I need to reconstruct the wall position. So I'm going to search for the one where I reconstruct wall position. And I think this is one of them. Like, I don't know if I did it here. I pass everything, but I never reconstruct. Yeah, I reconstruct. Well, don't reconstruct it. I have it. No, this is for the normal. So I'm going to go for this one that this has the wall reconstruction of the position. So let's copy this one because this is more interesting for me. Okay. So here, instead of using the UVs from the vertex, I'm using the IRS. Okay, depth texture, get the depth. If it's the skybox, nothing to do. I skip this pixel. Although skipping the pixels could be dangerous because if I skip the pixel, that means that if I don't clear the buffer, it's going to be noise. So yeah, well, it's okay. I mean, the thing is, if I don't skip the skybox pixels, they will have trash, garbage, because every time I move the camera, it's going to be maybe they are rendered or not. And as long as I don't read those pixels, it's okay. The problem is if I read those pixels and multiply them by the skybox, it's going to look like garbage. But as far as I understand, I only will read this texture on the pixels where I'm computing the ambient, and I'm only computing the ambient on the pixels that are not the skybox. So that means it should work. So here I have wall position. I don't need the albedo. I don't need the extra. I have the normal here. I'm not going to use it, but it's good to have it. And I only need these variables. This is the uniform. I can bring it from somewhere, so I go faster. I need these two ones. Okay, so now I have def and the inverse VP. I can reconstruct wall position. I'm doing it here. I'm reconstructing the wall position here. And I have the wall position. Cool. And now it comes the magic of the screen space ambient occlusion. Okay, So I'm going to need to, for every point on every pixel on the screen, I need to throw positions around it. So imagine I'm going to, let's try to go step by step. So I have one pixel on the screen, and I have the wall position. So I want to have random points around, okay, at a distance of not very far away, like maximum distance should be 1 between all these points. So it's more like points inside a sphere. Doesn't have to be exactly 1. It has to be at least 1, okay? And then I will read on the scene the depth buffer. How many points? The more points I have, the less noise it will have, okay? But if I put too many points, it's going to be slow. So let's start by thinking, how can, from the shader, have lots of points? I don't have here a function to generate the points. So that's why I provided a function. I don't know if it's here. No, sorry, in the utils function. No, I don't think I put it in the engine, the one to generate points. Let's go to the slides because it's there. So here, well, here's a little bit different. I'm generating the FBO, and maybe we want to get the blur. Yes, another FBO. Yeah, that could be useful. If we want to blur, we can generate both of them. But we're going to need a function to generate points. Okay, so that function looks very interesting. But I want to ask you something. So be prepared, your minds, because I'm going to ask you something. I want to generate an array full of points that are inside a sphere. Okay, imagine what I need is some sort of function to generate points. Okay, so let's construct here a function using the same approach as here, because this is going to be probably the same. So let's go like here. Okay, so I'm going to put this function, I don't know, here. Okay, let's check this function to see how it works. Okay, it's a function. This GTR, I'm going to remove this because this is no longer required. Okay, so it's a function that you say a number of points and the maximum distance from the center, and it's going to generate a lot of them. And you can specify if it's for an hemisphere or it's a full sphere. Okay, and this kind of function, a function to generate random points, is going to be always be useful. And so it's good to think about how you can generate a function to generate random points. So let's go here, maybe renderer, and I'm going to put it maybe, I don't know, here on the bottom. Okay, so we have a body for this function. So we're going to need to have the results stored here, result. Okay, and it's clear if I need to generate num points, I'm going to need to iterate anytime, like all these times. So I need to add, I don't know, it's imagine I have a point here, P, and I'm going to add it at the end on this vector. And finally, I don't have to, sorry, I have to return this result at the end. So it's going to be something like this, but here I have to do the magic, okay? Find random point inside the sphere. How can we do that? Before while you are thinking about the solution, it will be always important that if you make a function to generate something, you have a way to debug it. Because if I generate these points and I go straight to my shader, I don't know if those points are well generated, and I could end up with something that looks horrible. Okay, so first let's test this. I want to render these points on the screen so to see if everything goes well. Okay, so the best way to do that is I created here on my renderer, when I was testing things, something called debug points. Okay, this debug points is a steady vector of vector 3, so it's 4 points. And you can see here that what I do is I call this function draw points. I pass the points and I pass the color and the size of the points. Okay, by default, this function is this debug points is empty, so you won't see anything. Indeed, this function, if it sees that there's no points inside, it's going to skip it. Otherwise, it would just render. It creates a mesh. Okay, a local mesh, it puts the points inside this mesh, it uses a flat shader and renders the points. Okay, so it's a very simple function that I know that could be useful for you sometimes to have debug functions. So I can do that. I can do, I want to generate a random bunch of points and I want to render them. So let's do something. As far as I know, this function doesn't clear the points inside. No, it doesn't clear them. It accumulates them. So what I'm going to do is when my application starts here on the constructor, I'm going to just say that this is equal to generate random points, generate points. How do I call the function? Sphere points, sorry. Here. How many? Let's start by 64, maybe. I don't know. Let's put a lot. 1,000. It's okay. It's free. And the radius, radius 1, okay. And I don't want an hemisphere. I want a full sphere, okay. And I only want to see. I don't want to see the whole scene and the editor, blah, blah, blah. Only want to see this. So let's check to see how it looks like this one. Assuming there's no errors. It's compiling. Lately, my Visual Studio is going super slow when it has to execute stuff. And it crashed. Okay. I don't know why it crashed because I didn't do anything weird as far as I understand. The points, it was the unit points. Here, I create a vector. I iterate a lot of times. I push these values here. Let me go in the back to see what's going on, because maybe because I didn't render, because I commented the line that renders the scene. Is it skipping something? Okay, yeah, I know what it is. Because I didn't enable the camera here. Yeah, I was enabling the camera inside render scene. This is one of the first things I do, because I didn't enable any camera when the function here, the raw points, was searching for the camera. The current camera, this was null, and it was crashing here. Yeah, so always have a camera enabled. That will solve many problems. I could have done that when you create the camera. I put that camera, the first camera, as the current, it was equal to null, but I thought it would be more misleading. So as it would be nice to have here some sort of comment, say, hey, you need to have a camera. Anyway, so we have the scene, and here we have lots of points. Let's get closer and closer and closer. Well, all the points are in the same position, in the 0, 0, 0, okay? And that's why you see only 1 point, okay? So now, question, how do I generate points that are random around the center, okay? Remember, all I want is just given this is the 0, 0, okay? And this is the radius, okay? From here to here is R. I want points, like, I don't know, 64 points, whatever, that are all inside this sphere. They cannot be outside of this sphere. They all have to be inside this sphere. How can I do that? Suggestions, ideas, because it's good to think a little bit about this kind of basic problems. It's a very simple problem. You may face this kind of problems when you're working in any project, and it's always good to have a solution. Even if it's a crappy solution, it's a simple solution, at least you have something. And also, when you have the solution, you should test it. At least while you're thinking about how you can do this, I'm going to try to, I don't know, put some values here. I don't know, let's go with, I don't know, px could be a random value between 0 and 1. Let's go to see what happens if I put this. 3 random values. Let's see what happens. I don't see anybody typing. If these 3 random values, the shape I should expect has to be something that looks like a cube. And you can see it, but it's more like a cube because there are all values that go from 0 to 1, from 0 to 1, and from 0 to 1. So this is more like a cube. And if I put more points, it will look more. I'm going to reduce the size of the points while you are thinking about your answer. And so let's go to make it smaller. It will be a little bit better. Okay, so no suggestions, no ideas. Nobody wants to be brave enough to propose a solution for this very basic problem that you should be able to resolve even if you are on the first year of the engineering. I don't know if my connection got lost. I don't know if it's the internet connection on the university is very bad. Hello. 0 to 1 from a specific point to make a sphere. Yeah, that's what we have now. I have values from 0 to 1 from a specific point. What I want is a sphere. This looks like a cube because all the values are the same. So I want this to look like a sphere. Random points inside a sphere. Constraining the random value inside the radius. Okay, how you do that? How you constrain the random value inside the radius? Because as far as I understand, I mean, random is always a value between 0 and 1. The distance from the point to the center of the sphere is less or equal than the radius. Yeah, that's the rule. I mean, the rule that I'm searching is how to generate endpoints where the distance from the point to the center is less than the radius. That's the question. I mean, you're telling me that the solution is the question. So what I need is, how do you do that? What's your approach to do that? Here, I have a random position where X, Y, Z all have random values. So no ideas, nothing. Nobody else wants to try besides David, Julia, maybe, Laura, one of both. Just try to come up with an idea, a mathematical function, something that given a function that produces points that matches the rule that the distance of the length of this point position is less than radius. So it's just, I mean, it shouldn't be so complicated. Okay, I see you are not the kind of people who loves to think by themselves. You prefer to wait until somebody else solves this problem. Okay, not going to push it any longer, but I would love to see that at least you try. I mean, being an engineer is about trying. It's not about being right. It's about trying, because the more you try, the more closer you're going to get to the solution. So the more you are worried that your solution is going to be worse or bad, you're a worse engineer, because you are not trying. You are not thinking by yourself. And this kind of problem, this is a very silly problem, but you're going to face this problem many times when you're coding. You need a solution to a problem. And obviously, the first approach is I go to the internet and search the solution for that problem. But what will happen when you try to search for a solution and there is no solution on the internet, because this is the first time that you have faced this problem, and maybe somebody has faced this problem, or maybe because it's a very specific problem and maybe people hasn't reported this solution. In those cases, you better be a creative person, come up with crazy ideas, and if this doesn't work, then think about another crazy idea until you find one that works. So that's why I'm surprised that you tend to be the kind of people who are very scared of saying your ideas. I mean, I would love to see somebody say, okay, Javi, I don't know, normalize this vector. Let's normalize this vector. Let's something like this. Okay, if you normalize, how will this look like? You're taking the point and you're making the model of this point. Sorry, the file's already in execution. What? It's not an execution. Yes, it's an execution here. What will have you normalize a vector? The distance between here and normalizing the vector and multiplying by the radius. Okay, let's see what happens if you do that. For now, obviously, because I have normalized it, I didn't take into account the radius. You're right, because the radius it should be multiplied by the radius. But if you do that, you're not going to get a point inside the sphere. Okay, you're going to get points from... Oh, what's going on here? This lost. Oh yeah, I'm normalizing the points. So now every vector goes from 0 to yes, sorry, because this was going from 0 to 1. So this is only goes to 1/4. So to be fair, this should have been something more like something like this, probably, because it was going from 0 to 1. Now it will go from -0 to 0.5 to 0.5. Okay, and as you said, you're right. I should maybe say that P should be multiplied by the radius, but I didn't need to do that before, because if you remember, the radius is 1, so the radius was already 1. 1 multiplied by 1 doesn't change anything, but at least we have something that looks like a sphere. But these are points that are on top of the sphere, not inside the sphere. If you think here, you see here, it looks like a sphere, but you can see every single point is not inside the sphere. It's outside of the sphere. It's on the points above the surface of the sphere. And I want points that are inside the sphere, not outside of the sphere. Okay, maybe it's hard to see here. Let's try to put the camera slower. So maybe if the camera is slower, you will see it. You see here that all the points we have here are on the surface of the sphere, not inside the sphere. Okay, so this is not the right solution. This is an approximation, but it's not the right solution. So how can I take all these points now and at least be sure that they are not inside the surface of the sphere, but they are inside the sphere, not on the surface of the sphere? Any suggestions? Any idea? With what we have now, I mean, I don't think that you have to rethink everything from scratch. With exactly what you want, we should randomize the factor we are multiplying the point by. Okay, that's also could be. Instead of multiplying, I mean, we multiply by the radius, but we also multiply by a random value. And that will mean that the points will be between 0 and the outside position of the sphere, which is the radius. So if this value goes from 0 to 1, points will be spread all around, okay? And it seems it should work, okay? But if you do this, you will see that all the points, there's a lot of points in the center. Okay, they're in a sphere now. You can see it's a sphere, but it's more, there's more density of points in the middle than outside. And the reason why what this happens is because the points tend to go. I mean, when they are going far away, when they are closer to the center, there's more probability. Sorry, how to say it? You're reducing the sphere, and so I'm making this more possible that there are going to be points close to the center. Anyway. It's much more a mathematical problem. So anyway, not easy solution for this problem. Okay. So I have, if for now, for the algorithm we're going to do, I don't need to generate the points inside the sphere. I'm going to go with points that outside of the sphere. Okay, so we can just go with this one. But just as an example, that sometimes very simple problems, you will have to think a lot if you want to solve this. If we wanted to solve the problem, we will have to multiply by random and also multiply by some factor that compensates the thing that is going to put all them in the center of the sphere. Okay, so the problem with this approach, by the way, it looks nice. I mean, it looks like it's all the points are on the surface of the sphere, which is good, but it has a problem. And I'm going to show you the problem because this is a very common problem if you don't think too much about these kind of things, which is here. I'm going to make the points, the book points smaller, by the way, sorry. So you can see the problem better. Instead of generating 1,000, I'm going to generate 10,000 points. And you will see the problem with the approximation we have made until now, where we multiply, we normalize the random values. If you do that, the trick of having a random value and then normalizing it to have a sphere, what you're going to get, it's a sphere, but you're going to get something like this, okay, which looks like a perfectly sphere where all the points are outside. But if you look closely, you will see that there are more points on these areas here, the corners of the square of the cube. Okay, remember we had points that were evenly spaced on the cube, and then when you normalize it, you're pushing them outside. But the corners of the cube have more probability to have points because there's more area on the cube that are closer to the corners that to the sides. So you will have more points on this area here than you have on the rest of the cube. Okay. And if I put more points, you will end up seeing that there's like this kind of lines of points. Okay. You can see it, but maybe if you put it like here, you can see this area has more points. Okay, so as I said, not an easy problem, and be careful when you try to do these approximations. That this is not like this introduces some error because you are forcing the points to be more in some areas than in others, and you do that, well, this is going to produce artifacts in the render at the end when you use these points. Okay, so that's why I suggest to use this function, which is much more complicated. I got it from the internet. And I'm going to copy paste it here. No, I didn't get it from the internet. I got it from another researcher who was researching precisely this topic about how to sample points in the best possible way. Okay, so let's put it like this. Okay. Okay, and you will see now this function, it will spread the points inside the sphere, sorry, outside the sphere, on the surface of the sphere, but much regular. Okay. So let's go with it. So here are the points. And as you can see, points seem to be very, very evenly distributed. Okay. maybe it looks like there's a little bit more here and less here, but that could be an artifact. But they're very, very well distributed, okay? And as far as I know, these points are not only outside, but also inside of the sphere. Yeah, I thought I was going to request points outside, but this works for points also inside, okay? And if I want them to be hemisphere, okay, instead of a full sphere, just half of the sphere, it's very easy. I just check one of the components, in this case, the Z, and if it's smaller than 0, I invert it. Okay, so all the points that are on one half of the sphere are going to go to the other half of the sphere. So a very cheap way to have points when you have a function that works for the sphere. Okay, so this being done, okay, I can remove everything I did for this because we are not going to render these points. Okay, this was more an example of something as basic as generating points on a sphere could be very problematic. And as this, you're going to see other problems when you work in graphics if that happens. So let's go again to my render scene. Okay, and I can remove this because I'm not going to need to do this anymore. So render scene. Okay, here we have it. And we will render the frame on the third. Okay, so we have here the bind, and I like to tap these kind of things, so I remember where it starts and where it ends. And the same here. This starts here and finishes here. Okay. Cool. So I need to have the points. Okay, I need to have those points and use them on my algorithm. And so I can send an array of points. So first I'm going to generate the points. How many points do I going to need? Okay, let's call it the vector, vec3, and let's call it SSAO points. I don't know. Or let's call it random points. Yeah, because it's more general. Okay, and these random points, I'm going to initialize them using my generate sphere points. How many? Let's go with 64. Although it doesn't matter how many I generate, so I'm going to go with a big number and radius 1, obviously, and false. I don't want hemisphere. I want a sphere. Okay, and the thing is that I generated 128 because if I cut the first 64, it's okay. If I cut the next 128, it's okay. So I can use more or less if I want to. I can like generate a bigger one if I wanted to. So here I need to pass this to the shader, and I can do it using the uniforms3 array because this is an array. Okay, let's call this function uRandomPoints. This sorry, not a function, this attribute, this uniform, and I need to pass here the pointer to the first element. So from here I go to the first element and I get the pointer of this first element, and next the number of elements. Let's go with 64 for now. So now I have 64 random points on the shader, and it's complaining by something. I don't understand why. So probably I'm going to have to cast this. Yeah, because this function is expecting a pointer to what? Puntera vector. Yeah, it's pointed to vec3. So the first element is a vector3, and this is a pointer. Why is complaining? It doesn't make any sense. Let's go again. Random points is vector3. I think it's because of this probably. It's not going to complain now. Let me go to see this function because maybe I'm missing something. This is a function that you have to put a pointer to float. Yeah, it's a pointer to float. Okay, sorry. So that means I have to remove this. So this is the first point, but I need the pointer to the first point. So the pointer to the first point is .uv. Okay. In case you don't know what this .uv, the vector3 class I have here defined in my math here, the class vector3, which is around here, vector4, vector3, yeah, vector3, you can specify or accessing x, y, z, or you can specify by W, and W is an array of the 3 elements. And because this is a union, that means it's the same accessing X, Y, or Z than V0, V1, and V2, okay? So if you put V and you don't specify the range, the bracket, and then the position, this is the pointer to the first element. And this is what this function expects. It expects a pointer to the first element. This is more or less the same as doing this, if you want. Like I have the pointer to the first element, and then I can say I want to cast this pointer to a float. Okay, this is more or less the same because this is a point. If this is a vector 3. This is a pointer to a vector 3. And this function expects a pointer to float. Okay. Anyway, cool. So we have the points and we have the random points. So let's go to our shader. The shader is here. And we need these values here. So this is a uniform vector 3, u random points. And we say 64. Okay. So we have these points now. So now is when we have to iterate. Okay, so we are making loops. Okay, remember that loops is usually dangerous in shaders because some old GPUs doesn't support it. I have to put here the number of points, but instead of doing this, putting here the number of points, I'm going to define it like a constant or something more like I don't know, define num points as 64. So I can put here these num points, and I can put here this num point. That means that if in any moment I increase the number of points, I don't have to do everything again. And I want to count how many points are inside and outside. So I need to have something like outside. Okay, number of points outside. And if everything goes well, I will increase it. And at the end, I'm going to compute a value which is going to be num of points outside divided by num points. So if an outside is equal to num points, that would mean that it's 1. Okay, but because this is not a float, I have to cast these two values to float. And finally, this is going to be the output color I'm going to render. So let's go here and say that this is going to be output color is going to be this. Okay, so now I only need to compute here for every one of the values to compute if it's inside or not. So how do I do that? First, I have a position. I want to compute the position of this random point, and this random point is going to be on the pixel I have now on the scene. Imagine that if I have my scene, like I'm rendering this scene, and I have here, I don't know, a floor and a wall, something like that, and then rendering this pixel. So the idea is I take the wall position of this pixel, I add the random. Okay, so if to the wall position I add the random offset, is going to have a random position. Then I'm going to project it back here, check the depth, and see if the depth after projection is equal to the depth of the depth buffer. That will mean that if it's the depth after projection is closer than the depth buffer, that means its value is outside. Okay, so that shouldn't be very complicated. What I'm going to do is first I'm going to go to the random positions and I'm going to add it here. This random position go from 0 to 1, the distance from the random position. Maybe I want to multiply it by a factor, the radius. Let's go radius, and I'm going to put here as a new uniform float radius. Okay, so that means I can spread more if I want the points. Instead of being very close to the center, I can spread them more. For now, I don't know how much has to be the radius. I'm going to hard code here maybe a little bit of this radius, and later I will see what comes better. So this radius is going to be, I don't know, SSAO radius. So new variable, I have to define it in a way where I can edit it. And maybe I can put it here on the renderer here with all the variables I have already here. Okay, so I have this radius here and I have to initialize it. So let's put it, I don't know, I think it's going to be a big number. I'm going to start with 5 and maybe I will increase it. Because obviously I want to play a lot with this value when I'm editing. I'm going to put here, maybe that's this radius. So I don't know the distance, so let's go with 100, I don't know, or 50 maybe, I don't know, we will see. So now at least I have an option to test with my modifying this value to see if it looks right or not. Cool. So I think I have everything I need from the C++ side. The only thing missing now is the algorithm itself. So I have a point now, this post position is a point close to the center, and I need to reproject this point back to the screen. To reproject this point, to reproject this point back to the screen, I need to have the view projection matrix. And I'm not sure I have the view projection matrix, so I need to send it. So let's go here and say view projection. Because I need to, this point now, as I was saying, now I have this random point, I need to know where it falls on the screen. Okay, so for that, I need to project this from 3D to 2D. And for this, we need the VP. So as I say, I don't know if I have the VP. So let's go to my shader here and say, hey, why not you set uniform and send the view projection from the camera. Projection magic. Okay, so now I have the VP. It's here. So that's all I need. Only thing I have to do now is project this point from 3D to 2D. So remember how you do that. You take the pose, you multiply it, but remember that to multiply, it needs to have fourth component. So I'm going to put one on the fourth component. So I'm going to call this proc pose, which is more or less similar to what I did here, but it's in the opposite thing. And finally, I need to divide XYZ by the fourth component, W. Okay, and this is going to be this will contain on the XYZ, the coordinate, the answer in the XY, the pixel on the screen in which position it is. And on the Z is going to contain the distance, the depth that is here, okay? So now I need to know, okay, if I go to the depth buffer, the same depth buffer I was using here, okay? So this post depth, if I search for this XY, okay, but the problem is that this XY goes from -1 to 1, and it has to go from 0 to 1 when you fetch on a texture. So I have to apply the offset here, which is obviously if multiplied by 0.5 and add 0.5. Okay, so this converts from a range that goes from -1 to 1 to a range that goes from 0 to 1. Okay, so now I have the depth of this pixel, and here is the magic. If the depth I read from the depth buffer is bigger than the depth of this point when I project it to the screen, that means that this point is occluded, okay? Sorry, it's not occluded because the depth on the texture is farther. That means that the point is closer to the camera. So it's empty, so that means outside to be incremented. And I think that's all. I don't know if I missed something here, but should be something very similar to this. So I'm going to check on the slide to see if it's more or less the same as I proposed here. So here it says something like, I have to send all these things, the point, blah, blah, blah. It's the same I had already done. And reconstruct the wall position here. And it's exactly this, no? I also add a bias here, a tiny bias. Okay, that could be interesting to do. And yeah, I divide first the W and then the Z, but before I do the Z, I add here a bias, which I can do easily if I do it prior to this. And then I convert from the range. Okay, yes, exactly what I have. Okay, so I like the thing about the bias. The bias can help you to have situations where, okay, and the bias is because of this reason. So you understand. Imagine that I have this, I'm testing the same point with itself, and because I test with itself, it's going to produce error. So I have to at least if the point is very close to the border, it's very close to the border, but it's not on the depth buffer. I set it like it's outside, even if it's a little bit inside. Okay, so anyway, I'm going to put here something like, hey, go to the Z and subtract a tiny fraction, okay, to avoid rounding errors. Here say 0.05. Yeah, 0.05 is good. It's good for him. It's good for me. Okay, so that's it. I think it's ready. Let's try to see how it looks like. If my shader doesn't crashes, which it usually tends to do. It's still compiling. It crashed because it doesn't like this line. He doesn't like this line. Plot V is equal to, yeah, I have to do the cast the other way around. Damn it. I tend to do this kind of cast, but no, it's the opposite cast. It's where you specify the type like this. This is a float, and this is a float too. Yep. Okay. And if I go to the ferret now, because this is not an, it's in the ferret. Then if it's in the ferret, why can I see everything? That doesn't make any sense. What? If I go to lights, texture, the ferret, what? Okay, maybe I missed something. Ah, yeah, I know what it is. I'm silly. I'm rendering the SSAO buffer, and then I'm generating the illumination buffer, and then I'm rendering the illumination buffer on top of that here. So it doesn't make any sense. So if I want to see this buffer, I have to render it at the end so I can see it for now. And maybe I can have also some sort of if show SSAO, because I like having flags to control everything that happens on my engine, so I don't make mistakes when I'm working. So I don't want to show it by default, but on show UI, I want to appear function to that. Okay. So at least now, if there is any problem, I always can debug my SSAO. Okay, compiling. And here we go. Okay, we have something that looks a little bit like a buffer. There's some error. There's like probably an error here. So we will have to investigate what's going on. But we'll see now. But at least I can see it, and it looks a little bit like what I was expecting, but not exactly. So what I see is that it's when the distance between point and the around are too big, then appears. But if it's not too big, it doesn't appear. Okay, but remember that we have this factor here, so I can increase this factor to see if I can make it look better. With 50, there's something wrong. Let me see. Yeah, I know what it is. Yeah, 1 second. I think I forgot when I was reading the values here. So here I'm multiplying by 10. Okay. View projection P W, yes, yes, projection, yes. It's exactly the same I have. The only difference, I did this in 2 different steps. Okay, that's strange. 1 second again. Points outside, non-points, random points by multiplied by radius. I think I can remove this, by the way, for now. It's okay if I do that. And I do the divided by W of propose. And I read the texture from the def texture, which I send properly. I didn't do anything wrong. By the way, this size here should be the size of the textures. So I'm going to take the size from here better. Width. Hey. Just in case I modify in any moment this texture, because it could happen that I modify the size in the future, and that size I was using is the size of the window, but I don't want it to be the size of the window. It has to be the size of the frame buffer that I'm working on now. Besides that, I'm uploading the 64. Okay, I don't know if this is 64 floats or 64 random points. Let me see this on the other code when I upload the data. No, it's the size. It's the number of points. Okay, I was worried that the number of point that the function I was expecting here is 64 multiplied by 3, because every uniform 3 has 3 values, but no, it already controls this situation. Okay, depth texture 3, color texture, the normal texture we are not using for anything, so nothing to do here. Okay, I don't know, it's weird. I mean, it's not bad. It's just I was expecting something that looked slightly different. I'm going to try another idea that I have that maybe that can help. which is, well, let's play around a little bit first with the code to see how it looks like. So show me this and make this factor bigger. It doesn't look like it's working in linear space. That's why it's strange to me. Something weird going on. Because when I get far away, it's like there's a strange offset here. Oh, it crashed it. What? That's weird. No, it didn't crash, but I cannot control anything now. Okay, it was just the camera that has go crazy. Okay, I don't understand what's going on. So something I can do very easily, just to be sure that it's not the shade that I miscopied something, or when I was typing, I make an error. I'm going to go here to the code here, which I know I used many times and it should work well. I'm going to copy this code here. I'm going to put it here for now, just to be sure I'm not missing anything. So here. Oh, damn it. I killed the wall position. I need the wall position. Yeah, here. So everything is the same. Random points is got points, but it's the same. And this 64 is non-points. So I don't want to hard code things. So I'm going to put here non-points. Here I put the samples in number samples, increase, blah, blah, wall pause. Everything is the same. The only thing I changed that here is the U radius that I used before, and the rest is exactly the same with depth texture. Get the proc, yeah. Yeah, I do the opposite here. I start with the number of samples and I subtract every time is smaller. I don't think it's going to change. I think this is exactly the same code. There's only one minor change. I have to put this on the here. Okay. And is complaining also because what? It says this line has an error. Points of Y wall pause. Wall position, sorry, wall position. Yeah, no. Yeah, it works and show us this there. Okay, I got more or less the same, I feel. It's not using this one. Ah! Sorry, I didn't call it radius. But U radius is points multiplied by U radius. Yes. And wall position is this wall position. Okay. Why if I was modifying this value look? Ah, I'm silly. I modified the U points, the name here, but I didn't modify it on the other one. Always, if you modify the variables, always you have to remember to modify it on the when you upload the data. Here, don't stop here. So all the points were 0, and if all the points are 0, because I didn't upload the variable, I was putting everything. And it's not going to fix the problem, but at least it's going to fix the last problem I have. So my guess is that there's some offset on the depth buffer, but I don't understand why. Now it works. What was the difference with my code? It's exactly the same code. That's super weird. Anyway, I will recheck the video afterwards to see what did I do wrong, because I don't understand. This code is exactly the same as I was doing before. Well, I separate here. I divide by W, and I divide later. Oh, no, this is the same. Oh, yes, the Z. Okay, the error I was doing is I was doing the convert from -1 to 1 to 0 to 1 only to the X and Y, but I wasn't doing to the Z. And the Z also goes from -1 to 1, but when you read from a texture, it goes from 0 to 1. So I was comparing values on the range 0 to 1 with values of the range -1 to 1. So it didn't work. Okay, I forgot to put this Z. I put XY, but not the Z. Okay, anyway, this works now. It was a silly mistake. And I was thinking about something related to that when I was doing it, I think. Okay, but anyway, we have here our value. Don't worry about these kind of fancy things. As I said, we are not computing it for the pixels outside. I mean, if it doesn't, I mean, if you don't like how it looks like, we can do something more like this, like for pixel that is outside, I can say that, oh, imagine I have this value oh here. Sorry, this plot oh is equal to 0. Okay, so, or maybe 1. Okay, 1 is better. So if it's smaller than 1, then I will compute everything. Okay, so I'm just doing this to remove this ugly artifact. It didn't matter because, I mean, if it was outside, you won't have to use it. But anyway, so we have here, and we can control now if we want to make it bigger or smaller, the ambient occlusion. Okay, so you can see that it's not perfect, but at least it does something. Okay, some problems here. Let's see some problems. The first problem is the one we were discussing the other day. That, like, for instance, look at this. This area is very gray, and this is white. It's kind of weird because if we're generating, I mean, we will expect that here the points have the same color, but this is because we are not taking into account the normal, and also here, like you can see, like I don't know, these white areas, and it doesn't make much sense. It would be better to have something oriented to the camera. Okay, but anyway, this is something that you will have to do. Another problem you can see here is that this car here, for instance, is producing error here. You can see that it's saying that these points here, the points on the back of the house, they are being occluded by the car, which is very far away from the car. Shouldn't take into account. Okay, so that's why some of the proposals, they have another value here which says if the difference between the both values is smaller than some range, then you don't take into account that value. So instead of saying if it's smaller, you reduce it. You can say if it's smaller, but of an amount. Okay, so for instance, if this minus this is smaller than, I don't know, this won't work probably. I think it's the opposite indeed. I have to say this plus, no, yes. No, it was okay. Oops. Okay, this is not what I wanted. So if def, remove this, it's bigger than this. Yeah, something like this. So you can see now that the points that are out too far away, they are not affecting. The problem with this approach is that this number is constant, is linear, and the problem is that these values are not linear. And because you are doing a subtraction of two values that are not linear, this doesn't work. So you will have to linearize this value. Okay, I'm not going to do it now. If you want to try it, you can search how to do it. Okay, but okay. More or less, we have what we wanted to. Before I leave the class for today, now you will have to take this texture, pass it to the step where you're applying the ambient, multiply every pixel by the ambient, and then you will have something more interesting for the ambient light. Okay, you will see that now. For instance, below the stairs, there's a little bit of darkness stuff. As I say, because this is a screen space, the value is not constant. Like if I, for instance, if I go far away, it's the areas are smaller, but if you go closer, they will look a little bit bigger sometimes. And also because of the number of samples, you will see these artifacts that there's like these lines everywhere because, well, every point, depending on the point, applies something. So how can we mitigate a little bit this kind of banding when you have lines here? This is called banding. I can do it now because it's quite simple to do. Instead of using always the same order of the points, something I could do is rotate the points between pixels. So at least pixels that are not, when the problem is like if one pixel has the same order of random points and the next pixel has also the same order of random points, at the end, you're going to get always something that looks a little bit, well, how to say it? there's patterns and you want to remove patterns. Okay, there's two ways to solve this. One could be applying a rotation. So you rotate the points every time of like every pixel uses a version of the points, but rotated by some random rotation. And if it's random, you will see how this banding disappears. Other solution could be that instead of using like here that we're using for every sample always the same pose, maybe this can change, have a different method. So for instance, imagine that I say like J. Okay, if I do this, I'm doing exactly the same. Okay, but what I'm going to do now is I'm going to add here some random value, and having a random value on a shader is complicated because you want to have a random value for every pixel. Because I don't have a random value for every pixel, I can do some silly thing like take the coordinate of this pixel, the X coordinate, and multiply by some random value, and then add in the Y coordinate and multiply by some other random value. Okay, and then I'm going to do, to be sure that this number never leaves the amount of samples, I'm going to apply a module samples. Okay, so this value is going to be a very crazy value for every pixel. And the nice thing is that because I'm doing the module of samples, it's always going to be between 0 and the number of samples. Okay, if I do this, it's crashing. And it's crashing because I have to use maybe the mod thing. Sorry, it's not called samples. It's samples here like this. And this won't work now. It crashed. Yeah, sorry. It crashes obviously because you cannot do this 2 times. So I'm going to execute it again. Okay, so show you the. Okay, so I have here, and I'm going to make it bigger. Okay, here, as you see, there's a lot of banding, very easy to spot, but I'm going to go to the shader and I'm going to do this hack to see how it looks like. And it crashes again because must be integral. Oh, okay. This has to be num points because this is a float. Sample is a float? No, it's an integer. No, it's an integer. It's not, what? Why is complaining? It's saying that operands to must be in. Okay. It said this is not an integer, and it's right because wait, this is an integer, but this is not an integer. So I'm going to convert this to integer, and I'm going to convert this also to integer. Maybe that way he will like it better. Let's see. He was thinking that he was a float. Okay, it works now. And if I add here, you can see that the banding now is not very noticeable. Yeah, I was expecting something a little bit better. I don't know. Let's change a little bit these numbers to see what happens. Yeah, it doesn't change too much. Anyway, I'm going to apply the other solution, which is way better. I was expecting a little bit of difference here, but I can see it's almost not noticeable. Although this value, if I put something smaller, that's weird. Anyway, what I was trying to do is every pixel will have different points based on the position on the screen, but I don't know why it's not working. So I'm going to go with the regular approach I always use, which is I'm going to rotate for every pixel this point, this offset. Let's call it this offset. Okay. I want to rotate it by a rotation matrix, so they are always a little bit rotated. But I don't want to rotate them by any arbitrary matrix, and that's why I have a function on the slides that says if you want to rotate the vertices, how to build a rotation matrix. So the rotation is not like this one, it's another one, which is here. No, it's not this one. Yeah, this one. So let's take this one. Okay, 2 functions. One that generates a random value. Okay, we're using sinus of some value that we are going to pass here. Another one that constructs a rotation matrix. Okay, so we're going to use this one here to construct a rotation matrix here. Okay, again, rot. Okay, sorry, rotation rot is equal to here. I have to specify an angle. So I want to rotate them on the forward axis of the camera, and to get the forward axis, I don't have the forward axis, so I need to pass it. Yeah. So I'm going to pass the forward of the camera. Let's cut the front. Okay, so when I pass all these things, I also need to pass the front of the camera. Front, so from the camera. I don't know if I have a function to get the front vector. I don't know if this is the front vector. I think so. Yeah, I think it's the front vector. And then when I have the front, I'm going to construct a rotation matrix that is going to use the front vector. And the angle, I want to be a random angle for every pixel. So I'm going to call this function I have now, run, that I created here, but this function requires some value. So I will pass here the pixel position. I don't know, this pixel position. Yep. So I have now a rotation matrix. So again, what I'm going to do now is I'm going to rotate the offset. Okay, so I'm going to go to this offset, and I'm going to say it's equals to this rot matrix multiplied by the offset. But because this is only have 3 components, I now have to create the 4th component. And finally, I'm going to put back this XYZ. Okay. Cool. So now if everything goes well, every pixel will have a rotated version of the random points. And because they are random, they will reduce a little bit the banding. Let's see if this works. 1 second. The application is still running, so I cannot close it. So let's close it. Security again. And because now I'm applying random, I'm going to reduce the banding, but I'm going to replace it by noise, okay? So that means that, yeah, it will look a little bit less bandy, but it will look more noisy. So let's see it. And you can see that now, if I increase this, the banding is lost. So you don't see those lines so much, okay? But you see a little bit of noise, okay? But this noise is not so ugly. I don't know if you can see, well, you probably will see when you see the video in high quality version, but it looks much, much better than the previous one. Okay. Another problem I have here, I don't have to worry so much about this problem because it's supposed not to affect at the end, but just so you understand the colors, these colors, by the way, when I compute these values here, okay, the number of values that are visible divided by the number of total values, this factor here, this AO factor, if you think about it, it's a linear factor, okay? But currently, I'm just outputting this value, and I'm outputting it on the screen, and on the screen is not supposed to be linear, it's gamma. So because I'm doing that, this value is not properly displayed on the screen. So here, what I'm seeing here is not properly the screen space, I mean occlusion, because this is in linear space, not in gamma. If I want to just to visualize it, not to use it, because if I do this, I leave this line now, I'm going to add an error, which I can do something like this. Hey, I want to convert this out from linear space to gamma space. I can do this, and this is, I think it's the opposite. I never remember which one is the one. Yeah. This is more what I was suspecting of the values I will have. Okay, so it's not so dark. So anyway, that's mostly it. Look how better this looks now. You can see areas, dark areas here. And you can see, for instance, the tree. You can see, like, if I look from up, how there's like dark areas inside the tree. It's occluding the trees, occluding the side of the house, even though it's far away. It's not perfect. Also, the size, it's currently we're having this size to 21. I can increase it. The more I increase it, the less details I have. You can see that now the tiny details of the windows, I'm losing them. Okay. Here I can see the details of the windows, but I don't see how this car is occluding all the area around the car. If I increase this one, then it happens, but I see better how the car occludes the area, but I lose the details. I can fix this if I take the points I was generating before and I use a distribution that it's more, the points are closer to the center, which was exactly what David was saying before. I mean, if we apply the other random position I was generating before, there will be more points inside, and that maybe produces the effect that I see areas are outside, but I keep still some detail in the middle. I don't know. It's playing with these points could be interesting. Okay, and that's okay. Also, because I'm working in world space, these coordinates here are in world space all the time when I compute the positions. Sorry, here world post. That means that even if I go far away from the camera or close to the camera, the quality, the areas are more or less the same. If the problem with this approach means that if I have a very far away point like this one here, I'm computing the ambient occlusion using a fixed distance. And because this is a fixed distance, I'm just reading lots of value around a tiny area of the screen. So I'm wasting a lot of resources to compute occlusions with very, very tiny areas around. So that's why many engines, they don't use this in world position. They solve this in, well, let's say that the radius varies depending on the distance. So the farther it is from the camera, the more you apply the spread the points. I can do this easily now if you want to see it, because, well, it shouldn't be so problematic because we still have some minutes left. So if I had the position of the camera, which I don't have, so I'm going to upload it. Let's go here. Okay, so I have the camera position now on the shader. I can compute the distance of this point to the camera, which I didn't need it because I also have the depth, which the depth is a little bit like a distance to the camera. But anyway, so let's compute the distance. So in this case, the distance is here, world position, float this is equal to minus world position, and the length of this. This is the distance to the camera. So I don't know, I can maybe multiply this by the distance of the camera, although I'm not sure that this will work. Well, this is going to look horrible, I can tell you now, but maybe I can play around with it to make it a little bit better. The problem is this, well, the distance is going to be super big, super fast, so I will have to decrease this value a lot. But at least, let me see. Okay, so let's go here, show out. As I said, it's going to look horrible, okay? But if I reduce this enough, so here, okay. So let me see if I can maybe make this value a little bit smaller. Yep. Okay, so we have the same we have before, but the thing is, if I get closer, you can see how the area reduces. And if I go farther, the area increases, okay? And I don't know, some engines like to do this because, or they work also maybe not in world space, they work in a screen space. And that produces that at least you're always, when you're far away, you don't care so much about the small ambient occlusions, like the area is very close. You care more about the ambient occlusion all around the area. And when you're very close to an area, then you want the ambient occlusion, damn it, the ambient occlusion that is very close to the points, okay? So I don't know, some people like to do this, but this produces some sort of discrepancy because you can see there's a dark area and I get close and the dark area disappears. So it's not like perfect, but if you play around a little bit, maybe I put it like this. So when I'm far away, you can see how the ambient occlusion affects like house and the cars like more spread. But if I get closer and closer and closer, I see the ambient occlusion affects more on the okay. I don't know. I have seen people. I've seen screen space ambient occlusion having this artifact, and I don't know if it's better or not. I don't like it so much, but I understand why it could be here. Okay. So okay. So that's it for today. I think I managed to cover all the grounds I wanted to cover today. And you can see that the slides are updated. And remember that I will expect to you that you're going to improve this to use also the normal. So that means that you will have to rotate the SAO by the normal and to make it so the points are aligned with the surface, and you will see how that improves a lot the SSAO. Okay, cool. So no questions, I guess, as always. If nothing else, remember next week you have to send the assignment. And on, let's say Monday, yeah, Monday. So finish everything you have, and remember, check the points, because if one algorithm doesn't give you too much points and you don't have too much time, at least focus on the algorithms that give you more points, okay? At least that's always a good idea. Yes, sorry, good point. I can do it very fast because this is just one line. Thank you, David, for reminding me that one. What happens if we reduce the size of the SSAO, which is just one line, and maybe it's interesting to see what happens. So let's go to when we generate the texture here, And here I'm using the size of the frame buffer, which is the size of the screen. Okay, but I can do this. It's just very simple. I mean, I'm just making the SSAO buffer smaller. If I make this smaller, I still will read the pixels from the texture, but it will be that the output is going to have less pixels, because the output will have less pixels. I'm computing less times the SSAO, okay, 4 times smaller. And you can see that by doing this, it's going to look exactly the same from you probably on the stream, but this is, oh yeah, sorry. Yeah, I wasn't expecting this. 1 second. So probably there's two possible errors. One is that when I send the eres is wrong, but I fixed this one. The iris. Oh, yes, I'm reading the depth texture size. No. Use the buffer. Sorry, the view color texture 0. I was still reading the size of the full frame, not the size of the SSAO buffer, which is smaller, remember. So this goes like this. Okay. Now, I was complaining. Color textures. Okay. So, I mean, I need to pass to the shader the right size of the frame buffer. If I don't pass the right size of the frame buffer, when I compute the UVs are going to be wrong. And that was what's happening before. Okay, so now the UVs are good. And I can see if I show this, it looks exactly the same. Okay, it's just a little bit more pixelated. Okay, but if I compute like this, maybe you can see better the noise now, the noise I introduced it. That's why doing the blur is an important step, but I'm computing 4 times less, okay? As I said, if I blur this buffer now, and I apply it on top of the other one, I mean, I can do a very hackish solution now if you want. Yeah, let's try to do something very, very hackish now so you can see it. What I'm going to do is, instead of doing just overwriting the screen, I'm going to multiply this by the current frame buffer, okay? Enable, I'm going to enable blending, but the blend function is going to be, sorry, I don't remember how to make a multiplication of the, using the blending. I've done it in the past, but multiply, OpenGL, blend, multiply. Because it's a little bit tricky. You have to do this color one meter. No, it doesn't. No, this is not here one. Yeah. Yeah, now I remember. You have to say, I want the first color multiplied by this color and the other to be 0. I think it was something like this. I'm not sure now. Anyway, what I'm trying to do now is I'm going to render the illumination buffer, and I'm going to multiply the SSAO on top of it. Okay. So you this is not the perfect solution, but it will look like something interesting. Okay, so if I enable this, you cannot see, but now it's being multiplied. But the problem is that there's no much light in the scene. I'm going to increase a little bit the scene light so you can see it. So the screen space ambient occlusion is here. You can see that if I go here and increase this value, it's here, and I'm multiplying it by the color of the scene. Okay, and well, it's hard to spot the thing that this is a low res or high res. Okay, besides that, there's a little bit of noise. But besides that, it looks quite good, I think. So yeah, sometimes people like to use, but you can see here like this very pixelated artifacts here, because also when I'm reading the texture, I'm not using bilinear interpolation. Yeah, I should enable the bilinear interpolation when you read from the texture, which is kind of easy to do. It's just saying OpenGL some parameters. But anyway, it's one option. And the other thing I wanted to say is that this texture, currently the screen space ambient occlusion texture, contains 3 components. Here contains RGB. But if you remember, when I was creating the shader here, I was outputting the same value 3 times. So, I mean, I don't need 3 components because all 3 are the same. I don't need also 4 components, obviously. So there's a trick that you can use sometimes, which is saying that this texture is only using 1 channel. And I say to say 1 channel, you have to type that this is a GL luminance. And if you do this texture will have only 1 single channel. So no matter what channel you read, it's always going to have the same value. And because of that, you get exactly the same as we were getting before, okay? But this is a little bit faster because when you have less channels, there's less things to have to travel on the GPU. And because of that, the memory is a little bit faster, okay? So if you have to render something that only has 1 channel, always use an appropriate format. And there's a lot of different formats. I mean, here's 1 channel, 2, 4, but also there's different channels. I didn't talk about it, but has OpenGL supports something like, I don't know, like all these formats here. For instance, I want to have, I don't know, I was searching the ones with the A8. Yeah, I mean, there's formats where you specify, I don't know how to do it now, but you specify how many bits per channel. So something that say like R has to have 2 bits and G has to have 2 bits and blue has to have 8 bits, something like that. Okay, you can do this, and if you do that, what happens is that you can add more bits in places where having less bits can be a problem that produce artifacts. But anyway, in this case, it doesn't matter. For now, if you have problems with size and so, you can just render like this and it will apply. Okay, cool. Now it's 100% everything I want to explain. Okay, so nothing else. See you on Monday. And remember, because it's the last day before the assignment, you better be there I can help you a little bit. Okay. Cool. See you next week. Bye.